Welcome to this explainer on the 9700 biology, triglycerides, and ester bond strategy. See this molecule? It looks simple enough, but it's actually the exact trap that thousands of Cambridge 9700 biology students fall into every single year. Picture this. You walk out of the exam hall feeling absolutely certain you nailed section 2.2. You memorized the textbook, you knew the structures, you calculated the data perfectly. But then results day arrives and you realize you've dropped an entire grade boundary. So where do most students actually lose these easy marks? Well, you might think it's because the biology itself is just too complex. Actually, scratch that, it's a total myth. Ordinary revision fails candidates every year because they fundamentally misunderstand what the examiner is actually looking for. You can spend hours staring at diagrams of glycerol and fatty acids, but if you don't understand the specific assessment objectives, which target your ability to handle, evaluate, and reason with information, you are leaving seriously easy marks on the table. So, the crucial point is 0. That is exactly how many marks you're going to get for a calculation answer without clear working. And yeah, that's even if your final mathematical calculation is completely 100% correct. The examiner isn't just checking your calculator skills, they are assessing your scientific reasoning. If you just drop a number on the page when asked to analyze a triglyceride dataset, the examiner literally cannot see your systematic processing and boom, you get a 0. To avoid that painful 0, we need to look at the theoretical architecture. Ester bonds are essentially the biological glue holding the fatty acids to the glycerol. But understanding them is really about recognizing the crucial causal relationships and connections within triglycerides. Precise definitions are an absolute non-negotiable for top marks here. We aren't just identifying that an ester bond exists, we're establishing a framework built on evidence-based reasoning. Every bond formation, every structural component you describe in your exam paper absolutely must directly link cause and effect. And you know, if you don't make those links, you'll just end up as a statistic. These are the top 3 warnings pulled directly from Cambridge Principal Examiner reports, the people who actually read your mildly panicked handwriting. First up, the classic trap of using the wrong terminology for the given context. Second, forgetting to double-check units and terms during your data analysis. And third, providing generic textbook answers that just aren't specific to the experimental context provided in the prompt. These traps are incredibly easy to fall into, and they will absolutely destroy your grade if you aren't vigilant. Now, what's really interesting about this slide is this massive lifeline, straight from the examiners themselves. Even if your final answer is wrong, method marks can save you. This is what we call the method mark strategy, and it is a total game changer. Systematic processing in your answers follows a sequence, and examiners actually award marks just for that process. If you identify the key elements, apply the relevant principles, and execute your analysis with clear working, you secure marks simply for demonstrating the correct methodology. That's entirely independent of your final conclusion. Which brings us to a massive question. In just a moment, I'm going to reveal a really specific, hidden examiner clue that changes your entire approach to triglyceride questions. A clue that pushes average answers straight into the top band. But to actually see that clue when it's sitting right in front of you on the exam paper, you first need the foundational problem-solving framework that makes it obvious. Section 1, the framework. Concept to scientific reasoning. Deconstruct, solve, and evaluate. When you're faced with complex data, intricate graphs, or multi-step practical investigations concerning ester bonds, you can't just start writing. You need a highly systematic approach that hits every single cognitive domain the assessment objectives demand. Step 1, identify the given information from the stimulus materials. Step 2, break the problem into logical, manageable steps. Step 3, solve systematically, showing every single piece of working to capture those method marks. Step 4, check your results for reasonableness to identify any anomalies. And finally, Step 5, make justified, evidence-based recommendations. Following this exact sequence guarantees you are handling the information exactly the way the mark scheme requires. And when we apply this framework specifically to data interpretation, it streamlines into 4 rapid-fire steps. Extract, interpret, calculate, conclude. You extract the raw numbers from the tables or graphs. Next, you interpret the biological relationships behind those numbers. Then, you calculate the relevant statistics. And finally, you draw your evidence-based conclusions. Listen, if you skip the extraction phase and jump straight to concluding, your answer is going to lack the empirical evidence needed for the highest marks. Section 2, interactive challenge. Spot the error, fixing a flawed student answer. Okay, let's dive into this interactive challenge and test your active understanding. Let's put you in the examiner's shoes for a moment. Take a look at this flawed answer. It might look okay at first glance. I mean, it mentions triglycerides and energy, but it entirely misses the structural details of the ester bonds, and it lacks specific context. Now compare that to the top band answer. It's incredibly rich in correct terminology. More importantly, notice how it uses comparative connectives to relate the structure of the triglyceride directly to the data provided in the specific prompt. If I'm the examiner correcting that flawed answer, I'm looking for specific criteria, because higher-order assessment objectives demand true evaluative thinking. A strong comparative analysis requires identifying similarities and differences. It demands the use of explicit comparative connectives, words like whereas or conversely. And crucially, it requires supporting every single comparison with hard evidence extracted directly from the data. Which brings us right back to that hidden clue I promised you earlier. Here it is, cross-topic connections. The principal examiner reports explicitly state that candidates who reference cross-topic connections achieve significantly higher marks. The theoretical architecture of triglycerides isn't isolated. Top-scoring candidates demonstrate true evaluative thinking by taking their knowledge of ester bonds and integrating it with other syllabus areas. They consider different perspectives and justify their decisions with a much broader biological context. And this brilliantly illustrates the ultimate procedural framework for tackling absolutely any exam question on this topic. Deconstruct the question first, extract the relevant data, select your analytical framework, execute your analysis with clear step-by-step notation to guarantee your method marks, and finally, present your findings using the precise, correct terminology specific to the context. This right here is exactly how you systematically engineer a top-band response. Section 3. The final diagnostic. The hidden cause of lost marks. We've covered a massive amount of ground today, from method marks to cross-topic connections. But before we wrap up, we have one final hidden problem that can still completely sabotage your grade. What happens if your terminology is flawless, your method is perfectly notated, your cross-topic connections are brilliant, but you still score a 0? Sounds impossible, right? But it happens constantly. Why? Because all of that beautiful biological knowledge is useless if you fundamentally misunderstand the specific command words given in the prompt. If the prompt says evaluate and you only describe, you will lose the majority of the marks, regardless of how perfectly accurate your description of an ester bond is. Understanding the distinct cognitive domains targeted by these command words isn't optional. It is literally the absolute boundary between a passing grade and a top band. Therefore, mastering these command words is the mandatory next step to solving this final piece of the exam puzzle. To unlock that puzzle, you need to know exactly how examiners grade those specific command words. Are you describing when you should be evaluating? Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Jump straight into our next explainer on command words right now, and let's secure those top marks together.